We now discuss the solution of a problem from the section Sequences and Series. The given problem is related to arithmetic means in arithmetic progressions, and this question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The given question is, if n arithmetic means are inserted between a and 100 such that the ratio of the first mean to the last mean is 1:7 and a plus n is equal to 33, then the value of n is, we are given four options. Option A 21, option B 22, option C 23, option D 24. So we are given two numbers A and 100, and in between n arithmetic means are inserted between A and 100 in such a fashion that the first arithmetic mean, the ratio of the first arithmetic mean to the last arithmetic mean is 1:7. We are further given a relation between a and n as a plus n is equal to 33 and required to find the value of n. We now discuss the solution of the problem in detail. We are given that n arithmetic means, let's call them as capital A1, capital A2, etc., capital AN, are inserted between A and 100. This means start with A1, first arithmetic mean, A2, second arithmetic mean, etc., n arithmetic mean, etc., 100 are in arithmetic progression. Let D be the common difference of the above arithmetic progression. We are given the ratio of the first mean, that is capital A1, to the last mean, that is capital AN, is 1:7. This implies A1 by AN is equal to 1/7. How do we write A1? A1 is the second term. How do we get? For the first term A, add the common difference. A plus D is A1. How do we get 100? 100. Now from 100 subtract D, you will get AN. Right. So that's what this implies. A1 is A plus D by AN is 100 minus D is equal to 1/7. Cross multiplying and simplifying, we'll get 7A plus 8D is equal to 100. Now let's look at 100 in the arithmetic progression. That's the last term. This is first term, n arithmetic means, and 100. That means the 100 is n plus 2th term of this arithmetic progression. So term n plus 2 is equal to 100. Term n plus 2 is a plus the number of terms n plus 2 minus 1 d is equal to 100. And n plus 2 minus 1 is n plus 1 into d. So n plus 1 into d is 100 minus a, and d is equal to 100 minus a by n plus 1. Take this d, substitute back in the last equation, 7a plus 8d is equal to 100. So on substitution, you will get 7a plus 8 times d is 100 minus a by n plus 1 is equal to 100. Let's call this as the relation 1. We are given a plus n is equal to 33. So we write a in terms of n, that is 33 minus n, that is the second relation. Now substitute for a 33 minus n, then the above equation 1 will be in terms of n only, and solving for n we will get the answer. Agreed. So take 1 and 2, and for a you substitute 33 minus n. So 7 into a 33 minus n plus 8 into 100 minus a in brackets 33 minus n by n plus 1 is equal to 100. Take this and we simplify in the next slide. That's what we have. That's what we have. Now this will imply 8 into 100 minus 33 is 67, minus of minus n is plus n by n plus 1. This is the one. And 7 33s are, this is 231 minus n, and sending on the other side we will get minus 131 plus 7n. Agreed. Cross multiply. So you will get 8 times 67, 536, plus 8 times and 8n. And n plus 1 cross multiply. We will get minus 131 into n plus 1 plus 7n into n plus 1. Agreed. Agreed. Now look at the right hand side. This right hand side, when simplified, you will get you 7n square minus 124n minus 131 from this. And the left hand side is now written on the right hand side, 536 plus 8n. Simplifying, you get 7n square minus 132n minus 667 is equal to 0. We stop here, and every student will also normally do like this. So what we see is, we look at the options. What are we looking for? The value of n. The value of n. And taking this, factorizing, then solving for n, it will take some time, extra time. Instead of that, we look at this one. So if n is equal to alpha is the root of this one, then that alpha must divide 667. So in these four options, 21 does not divide 667. You can check it up. 22 and 24, they do not divide 667 because these are even numbers and 667 is odd. And therefore, now look at this 23. So 23 divides 669 because 23 into 29 is 600. So the only factor in these four options, 23 is the only factor which divides 667. Therefore, n is equal to 23. Why? Because 23 is the only factor among these four options of 667. The answer n is equal to 23, and that is the option C. So the answer is option C. That is the detailed discussion of the solution of this problem. We can stop here. But suppose a student says, no sir, I do not want this. I want to factorize. So the factorization is done and shown in below. So this is the factorization what we have done, and the factors are n minus 23 into 7n plus 29, and n is equal to 23, and n is equal to minus 29 by 7 is rejected because n is a positive integer. The answer is n is equal to 23. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of the problem from the section sequences and series, and from the subsection arithmetic progressions, and the question is based on arithmetic means. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.